Hello everyone, I am Sagar and today we are going to solve a problem that is easy problem and the name of problem is count pairs whose sum is equal to x. And the problem states that given a two linked list had one and had two with a distinct elements, determine the count of all distinct pairs from both lists whose sum is equal to the given value x. So let me explain you this question using the first example, that is we have given a first list and that consists the element 1 2 3 4 5 6, 1 to 6 element, and the head 2 that contains the element 1 l 1 l2 l3 11 12 and 13. Okay, now so let me see this question. So we have given a head 1 that contains the element 1 2 3 4 5, and there is a head 2 which contains element 11 12 and 13, and we have given a one more element x. In this case x is 15. So we have to in this question we have to make x by adding two element a and b. It should be x, and a come one of these element come from the list 1 and b should come from list 2. So we have to make a pair, and in pair one element come from list 1 and the second element come from h2. So for example we have to make 15. So we how can we make 15? By adding one element from list 1 and one element from list 2. So like oh, 11 and 4 we can make 15. Yeah, we can make. And 12 and 3 we can make 15. So we got two pairs, and so this is how we have to do. So let me tell you approach for this question. We have to make, by adding a plus b we have to make 15. That means a should be equal to 15 minus b, equal to 15 minus b, that is same as x minus b. So what I'm going to do, I will just put the list element of list 1 into an ordered map. For example, I will put 11 1 2 3 4 and 5 into my map. Then I will iterate over my list 2, that is 11 12 13, and I will when I will at 11 the element 11, then I will check is there x minus 11, is there element x minus 11 in the list in the map. X is 15 minus 11, that is 4. Is there 4 in the map? I will check. Yes, I have 4. Then I will take it and I will remove it. Okay, then I will get one element. I will increase my count by 1. Then when I come to element 12, if I am element 12, then I will check is there element like 12 minus, sorry, 15 minus 12, that is 3. Is there element 3 in my unordered map? I will check. Is there 3? Yes, I got my 3. Then I will discard it and I will increase my count by 1. Previously it was 1. Then I will increase it by 1 and it will change to 2. Then I check for 11, 12. Then will come to 13. X minus 13. That is 15 minus 13. That is 2. I will check is there 2 in my unordered map. Yes, I got my 2. I will take it and I will increase my count by 1. And previously it was 12 2, and I will increase it 1 by 1 and it will become 3. So I got 3 pairs, that can make 15. So let me check the output. Yes, you can see that there is 3. So let me tell you the approach. First, put put elements of list 1 into another map, and second, traverse uh, traverse to list 2 and check for pairs. So this is what we have to do. So let me take you to the editor and I'm going to code it. For example, I'm unordered map, or we can use unordered set also. So instead of using unordered map, I'm going to use unordered set. Unordered, unordered set, and the value is going to be int. I've named is st. I will iterate over head one. I will insert every element of head list one to my set. So insert head one, head one's data. Then head one equal to head one. Next one. I'm just iterating, over my list. So I hope you know how to iterate over list. In the second step, I will just declare one count variable that I can use to count the number of pairs. Now it's time to iterate over head 2. I will check st dot count x minus head 2's data. If it exists, then I will increase my count by 1. Then 2 head 2 equal to head 2 next. Then I counted my all pairs. Then I will at last I will return count. So let me submit this code. So you can see that we are getting correct answer. So I'm going to submit it. So you can see that it passed all the test cases. So let's discuss the time complexity for this approach. The time complexity is going to be big of n, because we are in the first phase we are iterating over our list one, and we are pushing it to set. It takes big of one uh, to push the elements in unordered set. And in the phase two, we are just iterating over our list two and checking for the pairs. So it's going to take just big of n. So overall the time quantity is big of n, and the space complexity for this approach is going to be big of n, because here we are using the unordered set, and where we are putting the elements of list one to the set. So it can go max to n. So the time complexity and space complexity are this. So this was all about today's question. Thank you.